In this video, we're going to understand the intermediate value theorem. It says, given the polynomial 2x squared minus 2x minus 3, what is the smallest positive integer a such that the intermediate value theorem guarantees a 0 exists between 0 and a? So just a quick recap, the intermediate value theorem states that if I have some function that crosses the x-axis, and I take some x value and another x value, and one of the x values produces a positive y value, so this would be a positive y, and the other x value gives me a negative y, then to go from positive to negative, because I have this continuous function here, to go from positive to negative, I have to cross 0 somewhere between the two x values. So what they're asking us to do is just to guarantee that there's some 0 exists between 0 and some other number. So basically all I have to do is I need to start plugging in integers, because they say positive integer. Plug in integers until I go from having a negative number to a positive number. If I plug in 0, so if I do f of 0, I get 2 times 0 squared minus 2 times 0 minus 3, which gives you negative 3. So this is my negative version. I'm going to plug in x values now, starting at 1, and I'm going to plug them in until I get an x value that is, or a y value that is positive. So I plug in 1. When I plug in 1, I end up with 2 minus 2 minus 3. That's a negative 3. So it's still negative, so that's not the one I'm going to use. I'm going to use f of 2 now. So that's 2 times 2 squared minus 2 times 2 minus 3. This would be 2 squared is 4 times 2 is 8. 8 minus 4 minus 3 is 1. So this is a positive number. This is a negative number. That means that between these x values, 0 and 2, there exists a 0 in there. There exists a solution in there. So we would say that a would have to be 2. To guarantee a 0 between x values 0 to 2. Or we'd say maybe 0 to a in the original problem, 0 to a.